Hello, my name is Danny Crockett, and I'm the CTO for SharkBite Tech. Today's discussion is the first of a three-part series that is designed to provide an overview of recent developments in WAN design. In particular, we're going to talk about how cloud services and technologies like 5G are changing the definition of the network edge. In this first part, we'll briefly walk through the evolution of SD-WAN up to its current capabilities. The next installment will identify how to deal with network edges that are beyond SD-WAN and enterprise networks. And then finally, in the third installment, we'll dig into the latest WAN acronym, SASE. SASE stands for Secure Access Service Edge. And we'll go into a strict definition of what really constitutes SASE, the problems SASE is designed to solve, and whether or not SASE finally provides the single comprehensive solution to a WAN that is secure, high performance, and economical for all edge use cases. Okay? Let's get started. As I mentioned for today, we'll talk about the evolution of SD-WAN beyond its beginnings as a technology to bond multiple network paths and transports to achieve greater aggregate bandwidth and resiliency between sites at a cost savings over MPLS. WAN architecture discussions have been dominated by SD-WAN for several years, and for good reason. DPI capabilities and URL inspection, combined with accurate application databases, have created an application-aware network that provides much more granular control of traffic based on a number of things like business priorities, quality of experience, user context, and security. However, since SD-WAN's origins predate widespread adoption of the cloud, it should come as no surprise that the problems it solves don't encompass all of today's use cases. And we're going to outline what those are as we walk through its evolution. Before we walk through SD-WAN's evolution, however, let's summarize the current problems and business goals that are driving the expansion of SD-WAN's capabilities. First, complexity and cost. So, today's WANs are hybrid. There is, as many of your applications, if not more, reside in the cloud than are being hosted by you yourself. They're either SaaS applications or they're your own applications that you have decided to host in the cloud, Amazon Web Services, Azure, etc. These hybrid WAN designs, when implemented on MPLS, are very expensive because of the backhauling internet traffic over limited MPLS bandwidth is expensive. And it also leads to a poor end user experience for branch users of cloud apps because of the additional latency. Secondly, it started probably with WAN optimization, but also next-gen firewall. There are a lot of capabilities that can be layered on top of a traditional MPLS WAN. Unfortunately, those tend to be implemented by, we'll just say, adding a box. So, reconciling app performance and secure cloud access with a legacy MPLS design often requires service chaining hardware and software at each site. Again, that add-a-box mentality. WAN optimization, next-gen firewall, secure web gateway. All this does is increase cost and complexity to address a tactical need while insufficiently preparing you for strategic long-term goals. Demand for bandwidth, there's always going to be demand for bandwidth. MPLS is an expensive form of bandwidth. Insufficient MPLS capacity and high latency results in a poor end user experience. Over 10 years ago, products that aggregated all available network transport between sites, that was the origin of what we evolved into SD-WAN. These products overcame the limitations of legacy routing protocols to allow load balancing across multiple transports, even when each path might have different bandwidth and delay characteristics. Unfortunately, even if you can aggregate all the bandwidth between sites, branch users of cloud applications have a poor end user experience because of the latency caused by backhauling internet traffic to the data center firewalls to secure them. So you can't fix everything with bandwidth. The legacy WAN is inflexible and fragile. And by that, I mean that is driven by, again, this service chained, add-a-box approach to adding tactical capabilities to your network. It requires, additional maintenance, management, and coordination of configurations, licenses, support contracts. Each capability in the stack may or may not require its own maintenance window. In all likelihood, it's not well integrated with the other components of that capability stack. So that's what makes it much more complex and therefore fragile. It's hard to keep all of these configurations in sync. So whether the box being added is physical or virtual, service chaining always adds complexity. And complexity is the enemy of stability, security, and manageability. Plain and simple. Poor or unpredictable performance. Again, one source is limited MPLS capacity, and the latency that causes definitely contributes to poor cloud application performance. With legacy routing protocols, you can't take advantage of all the available transport and leverage each for its strength in a dynamic and adaptable fashion. And you tend to be forced into this false choice between either the reliability and predictability of MPLS or greater and cheaper bandwidth that will likely have an adverse effect on real-time traffic, because we don't have SLAs for internet broadband. So how can that replace MPLS? Meaningful SLAs and resiliency equal to or greater than MPLS can be developed with broadband services through for lack of a better term, a RAID for the WAN approach to transport. The analogy isn't perfect, but much like we do in the storage realm, SD-WAN allows you to stripe data across multiple transports with varying capacity, latency, loss characteristics. It can immediately recover from the failure of one or more links while achieving overall greater capacity, performance, and reliability. One thing I would like to note here, though, is that the idea that with SD-WAN I can create an enterprise worthy network by bundling lots of subpar internet broadband is not truly correct. So I really would like to note that SD-WAN does not absolve you of having to perform due diligence on the selection of your network transport. We still need to pay attention to the combinations of last mile and middle mile that we're aggregating. So to continue the RAID analogy, when you build a storage array, you would be pretty smart to use hard drives that are rated for a RAID duty cycle. A traditional MPLS network is typically harder to secure. A lot of that is the desire to break out internet connectivity, direct internet access at the branch offices. If you elect to do that, It has often been done without proper security controls and capabilities. Um, you can solve that by implementing a next-gen firewall at each branch or by utilizing a firewall as a service. However, even when you do that, there are unmanaged device, BYOD, and mobile use cases that remain beyond your firewall. And we will discuss that at a later time as one of the gaps in SD-WAN capabilities. Poor visibility. Historically, visibility at the network device level has always been constrained to layer 2 through layer 4. The devices simply didn't operate on the data streams at a level beyond that, and therefore the diagnostics available to you were constrained in that way. Also, the metrics that you were given, such as net flow, were often in sampled form. Lastly, we've always been hesitant to use capabilities like net flow on the really crucial choke points like firewalls because we're afraid of impacting normal network operations. Also, from a visibility standpoint, the vast majority of application traffic now is encrypted. If it is a cloud SaaS app, it is absolutely encrypted. So that itself creates visibility issues, which can be addressed in numerous ways. But when you have an application-aware network, you have greater visibility at a minimum into at least which application and sub-application at that SaaS site is actually being utilized. So up to this point, historically, visibility has always been an add-on. I mean, we're used to, if we need to see into application level behavior on the network, it's almost always been accomplished by making copies of network traffic via taps, spans, packet brokers, and feeding it to dedicated tools for packet analysis, looking at things from an APM perspective, an NPM perspective, a security perspective. And more often than not, the packet broker must provide sophisticated hardware and software capabilities for services like decryption and deduplication. All of this represents a significant ongoing investment parallel to your network, yet more complexity, with a common result being tool sprawl. In other words, lots of tools and many of them being or underutilized. And we would like to avoid that, and part of the way we'll do that is to embed application level visibility into the WAN itself. So let's talk a little bit about the legacy MPLS network and security architecture, at least briefly summarize what it is, what its strengths are, and the problems, the additional problems that we're trying to address. So the legacy network was all about, the focus was on linking corporate sites together with the data center as the center of the universe. Our data center is not hosting all of our compute workloads anymore for most companies, and the amount of workload that is hosted off-site via either a SaaS application or hosting your corporate workloads in the cloud is increasing all the time. So that is a radical difference from the legacy, what the legacy network was designed for. So when all the traffic was on net and the bandwidth needs were relatively modest compared to today, the task of building a stable, well-performing, and secure network was fairly simple. And MPLS deserves credit for providing predictable latency loss and bandwidth with SLAs. But some of these disadvantages on today's hybrid WANs are becoming a compelling issue. One of the biggest problems, and this is related to that function stack that we talked about before, and service chaining, to enforce security policy. Your network sessions have to be forcibly routed to wherever the inspection engine or engines are. That can radically increase the complexity of your network. And to fully inspect the traffic, it has to be decrypted, which again requires that the inspection capabilities are in line with the network sessions. In particular, TLS 1.3 forces an inline approach to decryption because of the use of ephemeral mode Diffie-Hellman. The private key is one time only. It's transmitted in encrypted form. So only an inline proxy has the key required to decrypt the payload. So, the ability to be in line with the network sessions is critical, and it would be ideal if we could accomplish all or most of these operations with a single unified device and capability, rather than trying to farm it out to multiple inline devices. And as you can imagine, routing complexity skyrockets when we have to force more user, device, application services, and data into this model. Management complexity skyrockets. There's no doubt about that. And to provide secure web access and cloud access at a minimum requires a next-gen firewall. Today's next-gen firewalls have a range of capabilities which may or may not be sufficient for your use case. But the functionality of a secure web gateway, DLP, in some instances CASB, advanced routing, WAN acceleration, QoS, all these myriad capabilities of SD-WAN are just very hard. It's hard to roll your own and build it in the traditional way. And what you end up with is so hopelessly complex that it's not worth the effort, and it's far too expensive. Finally, legacy MPLS networks completely fail to effectively serve the dynamic requirements of digital business. Mobility, 5G, personal unmanaged devices are increasingly being allowed and are a part of the mix. And it's our job to figure out how to make that secure. Now, this diagram by no means represents everyone's MPLS network. It's meant to illustrate some general concepts. Here, what I like to point out is that if this looks like your network, MPLS has done a good job for so long that it's been pretty easy for many companies to continue to use it despite obvious issues for a hybrid WAN and its expense. So we've mentioned that MPLS provides expensive but predictable latency loss and bandwidth. But one thing we should note is that the geographic area served by the providers can be a constraint depending on the geographic reach of your company. This is another benefit of SD-WAN's basis on more universally available internet broadband. The maturity of the technology, of MPLS technology, how easily it works with legacy routing protocols, and how well understood the QoS capabilities are, those are all both strengths and weaknesses. From a routing and QoS perspective, MPLS is strictly layer 2 through layer 4. It's simply not application aware. This is especially critical since so many apps today run over secure HTTP. For a traditional network and traditional QoS mechanisms, how can I differentiate between different cloud applications? They all run over the same transport. So that is a critical limitation. In this example, we have redundant MPLS providers, but the traffic between sites is not load balanced across them. That's a limitation of legacy routing protocols. That represents wasted and very expensive capacity. Legacy WAN routing is not based on any measured real-time transport metrics like latency and packet loss. So from a routing and QoS perspective, it's not performance aware either or optimized. Now, if you were to implement, for example, Cisco's performance routing, the situation is slightly better, but you still can't differentiate between multiple applications running over secure HTTP, and that's the world we live in today. Also note that while the convergence time may vary, the rerouting of traffic on this network due to a failure represents an outage lasting at least several seconds, and that is not transparent to users. Here, we don't have a unified control plane for all network policy. So depending on how many layers there is to our capability stack, here I'm illustrating WAN optimization, but there could be other appliances in there, even for the legacy environment. So without a unified control plane, each device or class of devices must be individually configured. And that makes it difficult to implement comprehensive network policies consistently. I'll wrap it up with the fact that it's not impossible, but it's very difficult to implement granular segmentation across the WAN with MPLS. If you do implement it, it's definitely something that you have to work hand in hand with your service provider or providers on. Ultimately, we would like to be able to implement segmentation policy based on different traffic classes and or security requirements, similar to how VLANs are used in the data center. So just to wrap this particular slide up, to meet today's requirements, what we need to do is equal or exceed the reliability of MPLS while addressing its limitations in terms of business agility, application awareness, cloud readiness, and security. Before we move on, let's lay out the fundamental feature set for SD-WAN. It abstracts the network traffic management across the overlay IPsec VPNs from the underlying physical infrastructure known as the underlay. What that means is we can implement any desired WAN topology using IPsec tunnels and even create multiple logical topologies dedicated to each different class of traffic on top of a diverse layer 3 foundation. So each of these logical topologies can be treated as a separate WAN from the perspective of routing and QoS. And even though we typically think of SD-WAN as being over broadband resources, the underlay can actually be any combination of layer 3 transport, including MPLS. Branch simplification simply means that we achieve simplicities and economies and an ease of management by incorporating as many functions as possible into the SD-WAN gateway. So it's at a minimum, convergence usually means the SD-WAN gateway replaces your branch router, but it also might have WAN optimization capabilities, firewall capabilities, and so on and so forth. So just note that the ability to converge these services varies widely among vendors, and that's definitely something you want to look at closely. Zero-touch provisioning is definitely a foundational feature of today's SD-WAN. That's the ability to place a device on your premise remotely without the use of IT staff, assuming it has internet connectivity. It will reach out to the cloud-based SD-WAN console and retrieve its configuration. You can even have, and ideally would have, the configuration pre-planned and ready for it as soon as it connects to the cloud console. So that eliminates the need for IT staff to physically place and configure the equipment. The use of broadband internet brings a lot of benefits, but a prime one is that it reduces site turn-up time. It's so much quicker to get a broadband service established, especially at sites that are off the beaten path. So that is a significant difference versus MPLS. And what this essentially does is it really puts enterprises in control of all their moves, adds, and changes. You're no longer waiting for the cooperation and scheduling of the service provider to be able to accomplish all of this. SD-WAN's advanced routing protocols have many capabilities, but the original and the one that is a big economic driver for SD-WAN implementations is the ability to leverage all available network transport to bond those transports together to achieve greater bandwidth, performance, and resiliency. Use of inexpensive broadband brings some other options for remote sites that may have been economically not feasible. Among those, building out an HA capability, as well as leveraging more than one provider, internet service provider, to mitigate packet loss, jitter, latency. And note that bonding of transports works across any transport. They could be unequal cost paths. They can have very different loss, latency, jitter characteristics. SD-WAN can take all those into account in real time and steer traffic on a per packet basis across the best available transport. When we refer to advanced routing capabilities, and if our entire WAN is built upon an SD-WAN platform, the advanced routing capabilities of your SD-WAN platform can in fact be replace traditional WAN routing entirely. You gain capabilities such as we've mentioned application-aware routing. We've mentioned performance-based routing that measures latency loss and other parameters in real time, and the ability to have separate policies for each traffic class based on business priorities. That's very powerful. Direct internet access can be more sophisticated than just doing a split tunnel and saying if you're going off net, just go out the appropriate internet connection that's directly connected to my local SD-WAN gateway. Some vendors have solutions that look at cloud performance more holistically and may even measure whether or not other adjacent corporate sites might be a better jumping off point for best performance to that particular SaaS application, because each site could be using a different broadband provider, and therefore it seems counterintuitive, but the fastest way to get to your cloud app might be to go to an adjacent location. So it can be, your direct internet access can actually be quite sophisticated. And we have numerous mechanisms to ensure that critical traffic is delivered in the best possible fashion. You can implement forward error correction. I know that there are 911 call centers that implement policies such as simultaneously transmitting all VoIP traffic across all available transport, and essentially, the packet that gets to its destination first is the winner, and the other packets are discarded. And that way, in real time, without having to and obviously VoIP is UDP, so there's no retransmit, but this ensures absolutely the best possible delivery of that VoIP traffic. We've mentioned virtual WAN segmentation. There are just many. It's a very feature-rich environment and very unique to each SD-WAN vendor as to what their advanced routing capabilities are. Centralized policy management and orchestration, typically using a cloud-based orchestration platform, which is built on technologies that are more highly available than what you could build yourself. And just note that this centralized management, this cloud-based orchestration, is a crucial enabling technology for zero-touch provisioning. So that is, you may have to look at the security parameters of putting your network orchestration in the cloud, but certainly take into account that this is, the enabling technology for zero-touch provisioning. And once again, because the overlay is virtual, we can leverage it to create virtual WANs of varying topologies and characteristics in the same way that we use VLANs in the data center. And from a security perspective, that can be very powerful. The reporting capabilities, because the platform is application aware and the routing is real-time and performance-oriented, the real-time monitoring and historical reporting is granular, and it extends through layer 7. So to summarize, today's SD-WAN is more cost-effective, secure, and operationally agile than MPLS. Sometimes to see where you're going, it's useful to see how things got to where they are today. So let's start by briefly looking at how the SD-WAN ball got rolling. The primary initial driver for SD-WAN, before it was even called that, was to reduce the cost of MPLS when its pricing was at a peak, and to leverage cheaper ISP bandwidth through link bonding. So it wasn't a replacement for MPLS. it was a bandwidth supplement and sometimes a cheaper alternative to the second MPLS provider for failover purposes. So note that in the first generation SD-WAN, the WAN wasn't really virtualized from end to end. Matter of fact, we weren't even calling it SD-WAN yet. The improvements were really limited to increasing the bandwidth and availability of the last mile. The middle mile really just emulated dedicated or virtual circuits from the carriers. Still utilized routing protocols like BGP or OSPF. And so, again, from a topology standpoint, it simply emulated what we had built with MPLS. It was typically implemented with a central security stack at the data center, so that's where the corporate firewall was. This made management of security easier at the expense of branch office latency and end user experience to the cloud. As cloud usage increased, that degradation of end user experience became more and more of an issue. When this topology was implemented with direct internet access at each branch, security was often compromised by the very basic nature of any firewall that was built into the SD-WAN appliance. It was essentially consumer grade. Some companies address that by actually implementing a next-gen firewall at the branch locations. Many others did not. So this is definitely an area that needed to be addressed for SD-WAN to move to the next phase. So after the initial generation of SD-WANs, we actually got to the point where it's more recognizable to us today. So as more and more companies entered the SD-WAN market, advanced features such as the application-aware routing and QoS, virtual network failover and failback, dynamic link performance assessment, and zero-touch deployment, those all came to market. And the network functions now became virtualized as an overlay of services on top of an IP transport underlay. And that underlay, again, could be any combination of broadband or legacy MPLS-based circuits. So agility, a single management interface, and the alignment of WAN policy with business objectives now came to the forefront. Now it's more recognizable as the SD-WAN products that we see today. One thing I'd like to note here, the interplay and redistribution of routing information between the virtual network, the SD-WAN virtual network, and underlying legacy protocols is a crucial factor to the success of a SD-WAN migration. A lot of people have jumped into the SD-WAN marketplace. A lot of them really don't do justice to this aspect of it. So at a minimum, when it's all said and done, your SD-WAN is going to need to integrate with your interior routing protocols at the data center, sites that have large campus LANs, extranet routers, etc. So robust support for BGP and OSPF is a critical capability. Now, to address the lack of security related to first-gen direct access or off-ramp at the branch locations, SD-WAN gateway vendors first turned back to our old friend, service chaining. Traffic traversing an SD-WAN gateway appliance is internally routed, in this instance, to a VM of a technology partner's next-gen firewall to provide a full security stack implementation. There's some disadvantages to that approach. even though it is virtualized inside the SD-WAN gateway, um, each of these service change capabilities represents an additional management console. From a management complexity standpoint, we haven't really gained anything. Um, Typically, the performance capabilities of these VMs is very low. Compute and memory is not the focus of an SD-WAN gateway hardware. And so, a next-gen firewall implemented as a VM is only going to be suitable for smaller branches. Um, if the chained services are not deployed at all locations, so for example, at one of those sites that has a large local campus, perhaps I implement a next-gen firewall in that SD-WAN gateway, but I might not do it at a much smaller site. Now I have to deal with dynamically routing internet-bound traffic to WAN nodes on my network that implement the desired service. So that introduces latency back into the equation. And as always, every service chained instance represents a separate vendor, licensing scheme, maintenance contract, ongoing capacity planning. It just undermines the initial promise of a unified approach to WAN management. Firewall as a service providers entered the market to secure internet access at branch offices by establishing a VPN tunnel to the cloud firewall providers POPs. So you configure your SD-WAN gateway to have an IPsec tunnel to the cloud firewall. This is another way to provide the service, and when it's based on cloud scale architectures, rather than using either a VM inside the SD-WAN gateway, or some of these services are based on a VM of the vendor's hardware platform. In other words, it doesn't leverage cloud scale technologies to be able to scale elastically. But if it's implemented with cloud scale architectures, firewall as a service can actually be a very flexible and elastic way to service your traffic as your needs grow. And if your SD-WAN gateway provider has implemented the necessary APIs and integrations into its console, those security services can be configured natively from the SD-WAN console. So that's actually a pretty good solution. And the other nice thing about firewall as a service, it can also provide VPN access for your remote users so that you can secure their access to cloud applications. So rather than necessarily forcing them to tunnel back to the central data center to get behind the corporate firewall. One other way to approach that, instead of using firewall as a service, is to implement a next-gen firewall at each branch location. In this diagram, I'm illustrating the next-gen firewall separately from the SD-WAN gateway. SD-WAN products have evolved from numerous different directions. Most of the next-gen firewall manufacturers have added SD-WAN capabilities to their firewalls. And so even though I'm illustrating them separately here, typically that is a converged hardware platform. And so it would replace your router, your SD-WAN gateway, your next-gen firewall. Those would all be rolled up into a single hardware platform where, depending on what security services you have bought licenses for or subscribed to, can also act as your secure web gateway, add DLP and anti-malware capabilities. It can decrypt. It can act as a proxy, decrypt the secure HTTP sessions. It's actually a very powerful solution. It can get everything under a single unified management interface. Uh, the really the only real issue is, like everything else we've discussed thus far, is that the one thing it does not address are unmanaged or personal devices accessing cloud applications directly when they're off net. And that's a use case we're going to be discussing in our second webinar. It's outside the scope of what SD-WAN by itself can do. So let's start to wrap things up with some things you really need to think about as you're looking at implementing SD-WAN. So we've mentioned this before. Robust legacy routing protocol support is a crucial capability for any SD-WAN. This has been overlooked in more than one implementation, I could tell you, but it is crucial. So in order to achieve the desired routing behavior under all scenarios, at a minimum, a very feature-rich implementation of MBGP, to a lesser extent OSPF, is essential. Now, if your interior routing protocol is currently EIGRP, you've got your work cut out for you. You're probably going to have to consider switching over to MBGP before you implement SD-WAN. It's absolutely critical to decide how you're going to secure direct internet access at the branch locations. Generally, your choices are an on-prem firewall or firewall as a service. Pros and cons both ways, but it's a design decision that ideally you would make up front. You also want to consider, while you're talking to the security team, implementation of other things like WAN microsegmentation. These are very security impactful subject areas, and so involving your security team is critical because it has such a high impact for both organizations. We've talked about the variety of advanced routing methods. You really need to evaluate the range and capabilities that are available to you. As I mentioned before, dozens of vendors have jumped into the SD-WAN market. I mean, it's amazing to me how many SD-WAN vendors there are out there, but a lot of them implement zero-touch provisioning and auto VPN, and then they just call it a day. The number of enterprise-grade solutions is actually much smaller. So, for example, if you are thinking about having dedicated virtual WAN overlays for each class of service, if that's important to you, that's going to narrow the field significantly. Also, if you have a need for WAN optimization, that's going to narrow the field significantly. So just making a list of the things that you've got to have can very quickly reduce the number of solutions that you need to evaluate. The solutions vary significantly in the number of SaaS apps that they can detect, classify, and do routing and QoS for. So, a significant portion of your RFP and proof of concept efforts should be spent there. The solution needs to have a very feature-rich and robust API and to be able to integrate into whatever your operational and security stack is. There's been a lot of technology acquisition in this space, and the manufacturers have not always done a very good job of integrating their SD-WAN functions with their core platform. Similarly, a well-implemented integration of the orchestration, the cloud orchestration capabilities with one or more firewall as a service providers can be very crucial to simplifying the day-to-day operation of your SD-WAN and deploying both network and security policies. You need to consider what your method is going to be for remote employee access and contractor access for both on-prem and cloud apps. And you still have to pay a lot of attention to the transport that is selected for use with your SD-WAN. You might be able to get away with one provider of cheap and unpredictable consumer broadband, but generally speaking, we want to shoot higher than that, and you may even want to leverage an SLA-backed Tier 1 type of service. You might want to look into outsourcing to a last mile aggregator who can help you diversify your last mile and help you choose the best ISP for that location. Another thing to consider is just how rapidly this is all evolving. We've already progressed through several significant feature jumps in this technology. So just be aware that technology refresh could be a possible scenario even within a 3 to 5 year timeline. And that's a pretty short timeline for WAN architecture. Things on the WAN tend to move slower than that. This is another factor that you need to consider, and it's part of the argument that cloud-based SD-WAN as a service providers will make. We'll go into that more in the third webinar of the series. So let's wrap up and just close with what the critical limitations of today's SD-WANs are. Do not address mobile unmanaged devices that are accessing cloud apps directly. We're going to have to address that somehow. Cloud data access permissions based on granular context, such as user ID, what device you're on, what your location is, not addressed. Okay. On-prem, you would deal with some of that with a DLP solution, but for remote and unmanaged cloud users, that has to be addressed. The onus is still on you. You're still going to have to deal with the complex management of capacity planning, software licenses, support contracts, et cetera, ideally, you have settled on a solution that minimizes this complexity, but it's still firmly in the lap of network operations. New feature functions may accelerate the need for hardware refresh. These feature functions are very compute intensive. Your SD-WAN gateway may be limited in that respect, and so just be aware that hardware refresh could easily happen sooner than you would like it to. Probably looking at that 3 to 5 year time frame. Even though you have direct internet access, you could still be dealing with suboptimal routing within the cloud. That's a limitation of your ISP, their BGP routing, and their ability to provide the best performing route to SaaS providers. So direct internet access may still provide inconsistent SaaS app performance. And I like to put in a caveat about carrier managed SD-WAN offerings because they really just hide complexity and design limitations behind the simplicity of a monthly bill. So if you're considering this type of service, you really need to work hard to get under the hood, take a look at the underlying capabilities, and examine them against your long-term cloud strategy, especially as it pertains to mobile and remote users and securing cloud applications. So I want to thank you so much for your time today. I'm sorry that I ran long. This has been actually a brief and by no means comprehensive overview of what has driven the evolution of SD-WAN to its current state. I've tried to keep it vendor neutral and provide some concrete examples of criteria that you should consider. And lastly, I wanted to identify where the gaps are for SD-WAN and lay the groundwork for the next two webinars. Next week, we're going to address cloud security for remote users on unmanaged devices. And in the third webinar, we'll dive into what SASE really is, the problems that it solves, and whether or not it's a comprehensive solution for all network edge use cases. So I'm sorry that we've run out of time, but I want to thank you again. Have a wonderful day, and we look forward to seeing you on the next webinar. Thank you.